channel, and hope you are all doing good and also enjoying the Python skill series so far. Today's video will be a follow-up regarding the previous video that we did on the global pandemic analysis. In the last video, what we did was basic EDA, that is the exploratory data analysis, in order to understand how our data set looks like and what is the behavior of our data. And on basis of that, what we did earlier, now what we'll be doing is we'll be going to build a linear regression model. So today's video is all about building a linear regression model and some of the practices that you should follow and keep in mind when you build your first linear regression model. Okay, so since you know about this data set, there are 41 different columns and we saw the volume of the data that it has contained, and there are some missing values also. So before we build the model, we would like to know what will be our predictor variables and what is our target variable. So target variable is that we want to predict, and predictor variables would be that it would be contributing to the prediction. So it is in that sense. That is one activity, that is to consider all the 41 different features or all the 41 different variables for your model prediction, or to drop some of them. So when you drop these columns or drop some of the predictor variables, you need to give the justification. So justification is as in like why you have dropped that, or what is the reason behind that for dropping that. So when you work in some industries or a company as a data scientist or any data science role, what you do or which model at least you have taken, you have to give the justification for each and everything. Okay, so keeping in mind that we have to do some of the pre-processing again, like to drop some of the columns which are relevant to our model building, and also there are some NA values as we have seen in the last session, in the previous video. We want to do some of the additional tweaks before we build our model. So the model which we build is, uh, we can say it is a very good model, and it will perform well in the future for our prediction. Okay, so before that, I would like to introduce this code book. So this code book is in accordance with the data set that we use, that is the OWID data set which we have. And in this, whatever columns they have put in their data set, they have the description of each of the columns. And one way you can consider like which columns or which variables you want to keep for your prediction is just by reading this description. So this is an authenticate way you can do, but if you don't have the correct analysis of which to keep, you can put all of the variables and then you can so model. So with all the 41 different columns you can build the model, or by reading which of the columns are irrelevant for your model prediction, you can drop that and then consider only those which you feel that it should be considered or it should contribute definitely for your prediction. You can think in that way. So these are the descriptions. So I have read this. So this is for you to understand what these different columns and variables mean for your model prediction. But for EDA, you don't require this. Just when you do the EDA, that is for understanding how the data is, what is the behavior, and what are the different kinds of plot that will give you some meaningful insights for taking some action. So that's why I have not introduced this a code book in EDA video. So if you haven't watched that EDA video, make sure you watch that first and then watch this video. And also this video will be a very long video, so please uh, stay till the end. So just don't leave this video in between, because I'll be discussing some of the few things, but if you just skip them and later come back to some other point, then you won't get the correlation of why these things has happened. So my humble request is just to be there till the end of this video. I'll try to make this as small as possible. Okay, So we start with the basics of the initial model building. So we know there are some NA values in this particular data set. So what I do is I'll first check for before dropping this. I have say COVID dot is NA and dot NE. If I run this, you can see there are some true values, means in this particular column there are some NA values, and where it is false, that means there are no NA values. Okay, so like just only for two columns, location and date, there are no NA values, but for all the other you have true values. But somewhere you have to consider the columns, and somewhere you have to treat for the NA values. Just you can't drop the NA values. Even if you drop NA values, you have to give justification why you have dropped the NA values, or you have not considered that. So you have to think, or you have to give that level of justification for this. Okay, so having understood that there are many NA values, we'll just drop from the parent data frame, that is this COVID, drop NA, and we want to work on this COV. So now let's see in COVs there are any NA values. So in COV there are no NA values because everything is false. And as you see from the previous video, that when in comparison of India with China as well as Japan, the cases are very much high. As also compared to Germany, we did the plot, but it was not that significant. Only we could see the graph of India was very high. So the model building, when we do, we have to give the reasoning on what location we would be building our model, or for what use case we'll be building our linear regression model. So my take would be like I would be building for the India cases, because the cases are very high. The rate of infection and different other factors that is contributing, that is on a logarithmic scale. But if you take for some other countries, there would be not much in order for justification or for model building. So since in India it's a very high time, and since the cases are also emerging exponentially on a day by day basis, I'll be doing my regression analysis and building my model on that. So henceforth whatever we do, that is for India case. So I already have my data frame that is did before this. So I'll just now run this India case. So in India case, I'll check for NA values. If there are any value NA values, it will just pop. So these are the different columns. Now in this you can see all the 41 different columns. I have not dropped any of the columns. But if you want, you can consider this ISO code. So this is just the basic analysis that you do. See, when you read this particular column, that is, if I just zoom this, you can see ISO code. It's a ISO 31611 alpha 3 letter country code. Then continent of the geographical location, then location, and date of observation, and so on. So you can consider these are the categorical columns that you have in your data frame. So if you want to check what are the categorical columns in your data frame, what you can do is you can write India case dot describe, and inside this what you can write is include is equal to, and you can put O. So this gives you what are the categorical columns. So in this you have the ISO code, that is a categorical column, continent, that is another categorical column, location, that is another categorical column, and the test units. So if you see here test units, that is here, that is a units used by the location to report its testing data. So this can be considered as the personal protection equipment, PPE kits, and all those medical equipments for testing the COVID patient. So these are some categorical columns. So if you build a regression model, the most of the variables that would be contributing to it would be numeric values. So we have many of the numeric columns in our data set, but for the categorical columns won't serve that much purpose for model building. So I essentially decide to drop this categorical columns. So I'll drop this columns. So this is a syntax of dropping the columns. That is, I don't want ISO code, continent, location, test units, and also the date. So if your target is like to build a model for predicting something, so prediction takes all the variables which are not time dependent. You can build a model which is time dependent, but just with the date itself, the date of observation, you can't give much significance to it, or it won't contribute much to a prediction. So that is my take on this particular variable, that date won't contribute too much of the prediction. So if my target variable that I consider, that is the total cases that I want to predict per day, then there are other variables, that is new cases, then new cases, smooth, total deaths, new deaths. These are the variables that would contribute uh, much to my total cases, that is the prediction. So these variables have much more prediction power as compared to this categorical or the date column. Date is just a single value that is across the globe. So I don't think that would much contribute to this. But if you are doing any forecasting or time series analysis, then date would definitely be an entity for your prediction, or in that sense, date would contribute much to your activity. But for model building, I won't consider the date column. So I would be dropping these four columns: ISO, code, continent, location, and date. So you won't get any output for this, because internally it is dropped the column. And if I look at some of the tail, few of the data which is there, you can see this is how it looks. Instead of 20, I'll just print few of the columns. You can see it has dropped all the columns. And if you want again to see, you can write India case dot columns. So the columns which we have dropped above, now it is not there in your new data frame for India case. Okay, now one question is that when you do model building, uh, you have to also give justification, like why you require a regression model or why not a classification model. So for that also you have to give some statistical analysis on some basis why you want to go with this model. So for that, what I do is, this is a pair plot, but this pair plot is for all the variables that I did. It will obviously take some time. So instead of this, what I do is, now I'll just run for the NA columns, that is the sum of all the NA columns which are there in each of the variables. So this gives that, and this is the size of now my data frame, how it looks like. And this is after dropping the columns. Now see, this particular India case consists of NaN values. Now I want to treat this. One option is you can drop this, but that dropping would be significantly affecting your entire row. So if you drop NaN values, that would be like you will delete this record or delete this record, or wherever its presence is there, that entire row will be deleted. So dropping is not a wise idea. You have to think something else, and you have to identify on which column it is, and you have to take the appropriate action. Okay, So this is the same thing that we do. Okay. So here also we can see there are some true values for NA, and there are some false values, means there are no NA, means when you want to treat for NA values, you will be treating for all these columns. So we know from our inspection, these columns which are having NA values, these are numeric columns, so we can do some kind of aggregate operations on that. So we'll see what is the desired or the appropriate kind of treatment to this NA values. So this also will significantly affect your model output and how your model will behave. Okay, so now that we identified that these are the columns, and some of the columns here consist of NA values, our best approach would be to replace it with the mean value. Now, why mean value? Because the numbers that you see from this data frame, that is in India case, if I write like this, so just look at these values. So in this record, that is 21 to 20, there is a NA value, but in 21503 there are some cases like 70,114 and 68,894. So since these are floating point numbers or numeric values, there is an option like you can replace this with the average or the mean of that particular column. So what I do is I treat the NA values with the mean value. So we'll just check whether it is perfect or not. So my take on this is would be to replace with the mean value, because since these are not anything related to your blood sugar values or cardiovascular values, you don't have any such columns in this. And fortunately those columns don't contain any NA values. Like if you consider the cardiovascular death rate, that does not contain any NA values, or diabetes prevalence, that does not contain any NA values. So if NA values were present in this, then instead of doing mean, I would think of something else for treating the NA values. So for this columns, I would say like treating with the mean values would be a better option. So for all the columns that are there for true or which contains the NA values, I'll replace with the mean value of that individual column. So the syntax is like on this column itself, you call the fill NA method and the mean value of that individual column. So keep in mind, when you copy paste or reuse this code or snippet again and again, just change the name of the column, else it will be like you replace the column value or the mean value of some other column. So that should not happen, and just replace or put in place is equal to true. That means you don't need to save this again and again, means on the fly it will be reflected. Okay, so once this is done, and if we again type India case dot is NA and dot NE, and if I just run this, now you can see the data frame which is used for your model building, that does not contain any NA values. So we have done so far two activities of dropping the irrelevant columns which are required or not required for your model building, and second is the NA values. So NA values is in consideration with what thing you would be doing in the future. So as I said, if you had any different columns like this diabetes or related to any patient, so these are some individual data and these are some collective data or from a large population. So if you have a very huge population data, so taking the average and replacing that would suffice the need, and we'll see how our model will affect that. So these are our primary sanity activity that we do before building our model. So now what we do is, since I said like if I want to predict the total cases in India, so the new cases which are there, that would definitely contribute to the total cases and also the deaths which are there. So my thought is like when there is a death in some particular family, what happens is, or like the death is caused due to COVID, the person who has died or the victim, uh, his other members might also get tested positive. So that also will contribute to new cases, and therefore it will drive to the total cases in that particular country. So if my analysis is correct, or it should be the same thing. So that's why I just want to check whether doing a regression would make a sense, or should I go for any other machine learning model. Okay, so for that, what I do is, now I will do a bivariate analysis. Means I'll check whether my new cases, does it have any influence on the total cases. If you say like yes, it is there, but for a statistical justification, we have to do some plots. So for that, I'm importing the C1 library and I'm doing a bivariate analysis. And for this, what I'm doing is, so first I need to identify if there are any outliers in the data. So we have seen that we plot the quantile plot, and we take the 50th percentile, 95th percentile and 99th percentile, and we'll see how many observations are there in this and what are the deviations in this. So for that, what I do is, I'll first do the bivariate analysis. So for the new cases, and just keep in mind, we want to predict, that is a target variable is our total cases, and all the other cases apart from the total cases will be my predictor variable, which would contribute to my total cases. Okay, so I'll just check for the new cases, what is my quantile summary. So on the 50th percentile, I have 6,610. That is not that much significant. But for 95 percentile, which is the standard confidence interval which you take for any statistical analysis or for model building, there are this much, that is 86,884. And for 99th percentile, there is around 96,435. So there is a huge number of data points or some kind of variation which is there in this particular percentile. So now what I do is, I'll just filter this, and on basis of this, I'll plot a reg plot, that is a regression plot. So we have seen this code before in cbound library, so this is just a brush up of what these things are, just to make you understand like where these things are actually put. That's why I'm doing this different plots, or these are the basic activities that you should do before building your model. So model building is not a one time activity. You have to consider different parameters, and you have to understand different things, how they are correlated, and then based upon that you build your model. Okay, so these are the new cases. Okay, and I'm doing a filtration based upon the quantile for 50 percentile. Okay, so let's first do for the 50 percentile reg plot, how it looks like. So on the x-axis I have the new cases, and on the y-axis the total cases. So new cases keeps on changing, and the total cases will be dependent on that. So and also each of the locations will have new cases, but this is only just for the India case. So this is how my reg plot looks like. So for 50%, you can see that I'll just zoom this out, okay, so that it fits in the screen. So you can see uh, that the total cases, most of the points are lying in this region, and your regression line is hardly passing through any of the points. So you can basically count this, just one point, just only one point which actually fits onto this, and just all the other points have some residual errors. So 50 percentile is not good. We won't go with 50 percentile. Instead, what we go with, say, like we have our 95 percentile. We'll just run for 95 percentile and see how our rec plot basically looks like. So for 95 percentile, again, the most of my scatter is along this direction, but my regression line which is passing has only 1 point. Here also it's only just 1 point. Okay, and there are some other points, but we need to do some treatments, or uh, this diagram is not that extended. So we'll just look for 99th percentile also, whether does this give us a decent plot or not. So for 99 percentile also it is the same thing, just only 2 points are there, but with a uh, on a standard or a gold standard notation, we'll go for 95 percentile, but we won't consider this. Just this was a basic check, like whether to uh, consider building a linear regression model or not. So we can see, like, since most of the points are not scattered but only few of the points are there, we need to do some kind of pre-processing over this, so that our final model which we build will be a good model which have much higher accuracy. Okay, so we decide that we go with a linear regression model. And one thing that I want to make sure is that we have seen a video, or I have made a video on linear regression model on the PIMA Indian diabetes. So there in that, what we did was we used the sklearn library. So as I mentioned in the k-means clustering video, sklearn library will not give you much idea of what the things are happening behind the hood. You need to devise some other method or for model building, so that you can check how well is your model, because just by looking at the intercept and the coefficient value, you can't say like your model is performing good, or the model which you built is a very good model, or it will withstand in the future, or in production when you deploy that model maybe it will fail. So then how would you decide, or how would you basically build your model from scratch? So for that, what we have is something called as a library, statsmodels.api. So this is the first encounter of the statsmodel.api, from where we'll be building our model. And this is are the various libraries, and this is the sklearn library for linear regression, and for Statsmodel, this is the library that we are going to use. And the train test split, what we do is, that is the normal sklearn library that we have, but for model building, that is a linear regression model, will be based upon the Statsmodel. And for the outliers, and there are some assumptions that the linear model will follow, that will consider in some other videos, but this video is just solely for the your regression analysis. Okay, so we have said like the total cases that we have, that will be our target column. So let us go and initialize the target column, and this is how I split my data frame. So on the X, uh, that is, I have this syntax, that is, I want all the columns or all the records, and the columns which is not the target column. So everything minus the target column will be stored in my X, and on the Y, that is, which keeps on changing, that is the total cases, is what it keeps on changing every day, that is the dependent variable, and X is the independent variable. So this is how I store this in X and Y partitions. So based upon the partitions that we did, So if you want to see this, what does X contain? So X will contain everything apart from the total cases. Okay, so if you see, after dropping the columns, we have 35 columns left. So initially when we did EDA, we saw there were 41 different columns. Now it has been reduced to 35 columns, and since we are looking only into the uh, cases of India, we have 292 entries for that. Similarly, if you do for Y, that is, which will contain only the total cases which are there, that is name total cases, and this is the length and the similar number of entries. So if that is cleared, then what we'll do is we'll do a train test split, the same thing that we did for the SQL model building linear regression. These things remain the same. So we have the X train, X test, Y train and Y test, and then we do the train test split. So this is how we do, and we keep like 70% of your data in the training set, and for the test set size we keep it as 30%. So a 70-30 ratio is followed for partitioning, and the random state, that some randomness you have to introduce, else everything will be going into the training set and not few of the instance will be going to the test set. So in order to have some kind of randomness, we are introducing a random state and it is kept as 42. So this is a standard. You can try this for the initial checks. Later you can tweak these parameters, and then you can see how your model is performing. Okay, so I just run this, and this is the part where it takes a U-turn. So instead of directly calling the linear regression model from the sklearn library, we will build using the OLS. So OLS is nothing but, if you just hover on this, so you can see OLS is simply an ordinary least squares model. So I have made a linear regression video which explains the conceptual part of how a linear regression model works. So in that we see the line which is passing, or the regression line which you fit, that should minimize the sum of squared errors. So OLS, that is the ordinary least squares model, is something which will minimize the sum of squared errors between your points and the regression lines. So that is our major goal. Like whenever you have a distribution or a scatter of different points, it should cover all the points which are there in this part. So our goal is to make such a line which will pass through all of the available points which are there. It should scatter most of the points. So this is how we build our model. So now we want an intercept, that is, we have the equation y is equal to mx plus c or ax plus b. So we will have a intercept, that is x with constant, and we'll write sm dot add constant to x train. So mx plus c. So this is the training data, and to training data we'll be adding some intercept like c. So this is in with that analogy, and this is my model, that is the OLS model, Statsmodel dot linear regression OLS model instance. And this is how I call my model, that is sm dot OLS. Sm resides inside the statsmodels dot API, and inside that I'm passing the y train and this x with constant. So this is how I build my model, and now I want to fit my model and get some results from that. So that's why I have results is equal to model dot fit. And now I will see what are the different parameters in this. So the columns that we have dropped, it is not there, but the other columns, that is the 35 different columns which we have, these are the different parameters which contribute to your prediction. Now, how would you evaluate like the regression model which you have built from your OLS is perfect? So for that, what this stats model gives you is something called as results.summary. So when I run this summary method, it will give you a detailed idea of the regression results from your OLS model which you get, and you have some parameters. There are many different parameters which you see from this, dependent upon the number of predictor variables you use. Since there are 35 different predictor variable, you get a big different chart. If you have like a dummy data set, then you will have 3, 5 or 10 different predictor variables dependent upon how many you take for your model building. So not everything you want to understand from this, just only the thing which is relevant for your model building, or what inference you make, or by reading this summary result, how would you evaluate your model, or what you want to say about your model. So first thing, if you see the dependent variable that you see on here, that is the total cases. Yes, we have decided that our target variable would be the total cases. The model that we are using is a ordinary least squares. The method is, name of this is least squares. The date when it is run, that is the 18th October. The time when it is run. Okay, so I have already run this before. So this is that time, the number of observations, the residuals that it is getting. So this thing signifies, or this date signifies, the time signifies when it is initially run. And there are other parameters, the residuals, then the DF model. And the important thing which you need to look into is this R squared. So if you have a cluster ready by using k-means, and if you want to evaluate that, there are different methods like silhouette coefficient or cohesion separation. Then you have external measures like Rand index or Jaccard index, things like that. But for regression models, how would you evaluate? So that is evaluated by using the R squared value. So any value of R squared which is closer to 1 indicates that it's a very good model. Means what R squared value tells is that your regression model consists of those parameters which are relevant to your model prediction. And if you took some variables which are irrelevant to your models, that will be penalized in this. So adjusted R square value will penalize your this R square value for considering irrelevant attribute values. So since here we have uh, the value as perfectly 1, that means our variables which we have taken for model prediction is a perfect take that we have decided. And then what we see, that is the F statistic. So F statistic is one such parameter which is used in statistics, called as the test statistic, for which you decide, like, if you have a value that is a very high value. So in F statistic you should ideally have a very high value. Here you have some around very high value, that is 3.36 e plus 14. That is a very high exponential value, and the probability of this very high value would be approximately equal to 0. So this probability of F statistic is nothing but the p value which you say. So especially in drug test or drug discovery, so tomorrow if in for case of corona uh, or COVID vaccine, if you discover some disease, then what the statisticians will do is they will check for the p value. If the p value is very lower, then you would accept that drug, or if it's not that good, then you will reject that. So they do kind of this statistical analysis on that. So here for our model, what the probability value or the p value says is like it is equal to 0. So that means the model which we built and the variables which we have considered and the pre-processing techniques, including filling the NA value, all these things are appropriate to our model building. And there are some log likelihood values which are to the negative scale, that is of minus 66.425. Then there are some other values, and the thing what you need to look into is this particular summary or this particular table. Now what this says is like the predictor variables that you have for your model prediction, that is a new cases smooth, total deaths, these are the coefficient values. So if you have the equation y is equal to mx plus c, so in this you just have only one variable that you predict. So for y is equal to mx plus c, you have only one predictor variable. Now in this case you have 35 different predictor variable. So with each different variable you have the coefficients. So this is that coefficients. Some coefficients can be negative, some coefficients can be positive. So that is not a problem. But the main thing that you want to look is the t test. So on basis of t-test it calculates, and this is what you want to look. That is a p-value. If it's greater than the mod of t, so that is a positive comparison that you are doing. So the p-value, if it is closer to 0.05, that means it is very good. I said it is closer to 0.05. So if you look at this value, that is the p value for new cases, it is 0.454. uh, it is not that bad, because if the p value is closer to 1, that means the p value you should reject. Okay, so that says like if you do the hypothesis testing on this, and the null hypothesis of an individual feature is that the feature value is 0, then you accept that hypothesis, else the alternate hypothesis is accepted. So the basic thing that you need to keep in mind, that look at the p-value. If it is less than 0.05, then reject the null hypothesis and accept the alternate hypothesis. Means rejecting the null hypothesis means like rejecting the variable, or like the variables which does not contribute to your model prediction. Just reject that and accept what is there given by your prediction. And if it's not that the case, or if it's greater than 0.05, then what you have with this, you have to take with that, or you have to go with this model building. So here if you do further analysis, that is the new cases smooth, that this is particularly in the range of 0.05, then new deaths, total deaths, then this value, that is the total cases per million, this is almost, or it is exactly equal to 0. So this is on a very large scale which you do the prediction. That's why you have a very good correlation, or the p value which is even less than 0.05. That means this particular variable is very much contributing to your model prediction. So you get to see like what are the different variables and how it is actually contributing to your model prediction. So that's why, or that's the reason why you got a very good r squared value and the probability value is 0. So ideally they should be close to 1. So now in this case I'm getting a value close to 1. That means whatever we have did above, that is very good activity. And if you look down, so what you need to look into this and what you need to remove. So if you look at this value, that is 0.966, so this is for positive rate. So if you look at this particular code book for positive rate, what it says is that the share of COVID-19 tests that are positive given as rolling 7-day average, this is the inverse of test per case. So what our p value says is that its value is very much closer to 1. So if your value is very much closer to 1 or greater than this, we reject this. Means we don't want this positive rate as a variable which should contribute to our model prediction. So now later when we do the model rebuilding, we will drop these columns and then we see how our model is, or there is not any more to improve, but just to make sure like these are the activities that is done. If this particular result was bad, then how you could improve your regression model. Then what you see is this median age. So this is the median age, that is 0.929. That is also having same values. Though the median age, if you see the description, median age of population, so that is a United Nations projection for 2020. So you can drop these values because that does not contribute much to that. So on a statistical evaluation, I am saying this not just by reading what the description is, you can see from the results. Then there are some other values like this value, that is 0.955, and this is like hospitals beds per thousand. So it's like only if you are tested positive, then you have to go to hospital and get admitted. Then if you go to hospital and book some ward for like your beds, then that would contribute, but only if you are tested positive. So this also is not that good predictor for your target variable. So you can definitely uh, drop this column also. And the life expectancy, so that is also 0.914. So even if your life expectancy, if you have 70 years of age, if you get this uh, disease, then your life expectancy is also reduced. So that does not make much for your total prediction. So my analysis would be to drop this four columns, that is life expectancy, hospital beds per thousand, and median age, and also the positive rate. So now what we do is we just drop this and we do the model building activity again. So we'll rebuild the model. That is not much thing to consider. Just you need to understand this summary table, what it conveys, and you have to take action according to this. Okay, so now since we have decided like these are the stats, so now we'll do the model rebuilding. So now I want to drop the columns. So I have these columns as I've said. So I'll drop these columns and I'll just have a small glance of my India case. So instead I'll write columns. Okay, and I'll get this as my columns. So you can see the columns that I've dropped, it's not present here. Okay, and that is the same thing I've done. So now what I'm doing is, instead of x and y, I'm replacing the variable, else your model will pick up the old x and y and you'll get the same results again. So instead of that, I'm replacing x as a and y as b, the same thing which you have seen. Just after dropping the columns, we'll see what output we get from this. Okay, so again a train test split on this, and this is my OLS fit. I'm fitting a model, and this is my results parameters that I get. Okay, so now here you can see the older four predictor variables which was contributing badly to your model, you have now eliminated from your model building. And now if I print the summary results, I'm again getting the r squared value, that is 1. So as before, so the adjusted r square is also 1, the p value is also 0, and if you see down below, you can see the value. Now the p value is somewhat decent. Now it's up to you, like see as a result of that, these values have been normalized or they have been reduced. So initially, if you look the previous test summary, what you get is so see here, because of that there were like some changes. So these values have been changed. So somewhere the other they were dependent, but now they have all been scaled to some decent value. So now you can see the difference in these other values which were earlier dependent on that p values which were very higher according to our test statistics. So now since we rejected that and we are keeping only these many columns, that now we have 31 different predictor variables for our model, we can say that this model that we built for our linear regression is a very good model. And make sure like always build your linear regression model from Statsmodel and not from sklearn model, because you can't make much judgments and evaluations of how good your regression analysis is. So this is what my model is. Now in the next video or in the upcoming videos, we'll see some of the assumptions that what my linear regression model has to satisfy. So when you build some model, you have some assumptions like it has to satisfy so and so rules and regulations. So for that, we'll have four basic assumptions that any linear regression model which you build must qualify. And then later I'll use this model for predicting the cases based upon some of the uh, coefficients or variables that I have. So this is what my model has to say. The model which I built, or from my analysis, it's a very good model. Now as a human being also, I have something to say based upon this. So since I'm from India, and you know, I have done this analysis on this. So this data what I get is from the OWID dataset, that is a world dataset. They keeps on updating, so it reflects what the current situation is there in our country. So people who are watching from India, if they are looking into this video, getting the different statistics, how this basically works and how data science relates to your life. So if you think like this makes some sense, so my humble request is like just to stay at home, work from home, and follow these safety measures. Then if you see, like if you want to develop any vaccine, it would definitely take some time. So and that time is also like variant. You can't decide when the vaccine is being produced. So till the time, just don't go outside, and just like uh, eat the homely cooked foods. So that is a best medicine. Food is the best medicine, or food is the best vaccine, I would say. So instead of investing time for building new vaccine, increase your productivity, and increase, like learn new skills, cooking skills. You should be able to uh, learn cooking in the future. So I know that I'm deviating from the topic for this. So if you want, you can stop this video, but I have to say something on this. So what I want to say is like cook your foods by your own. Just don't go outside to buy some foods, because you don't know from on what hands it gets, and it gets contaminated. So still the cases are on a very high rise. So and then in the upcoming months. So now, since it's a month of October, and since it is started in the month of March, almost the year has been passed. Now just only few months are left, just November and December. So and also this is the very like top period for your festivals. Now since there will be different festivals that will be coming, so just follow the regulatory measures. Just don't visit like how you used to do before, couple of years ago. Stay at home. If you want to speak to anyone, use mobile phones, or you do the video calling, Skype, and different technologies are there. Make use of that. Stay home, stay safe. So at least think of your children, like they are sitting at home and studying. So at least like think about their future. So tomorrow, like not tomorrow, if at least like in next year you don't want to have this. So this data what I get is not like what I do, or it's the global data what they release. So if you want to see any decrease in this rise of the corona which is there in India, obviously you should take some inputs. So I believe most of the people watching this video are from India. So this video is for them. So you can share this video. You can say it to people. Okay, this is how it is done. So if you uh, just say something like without any basis, like I can make a blog on like current situation of India, but that would not make any sense. So this is how I give you the proof, like these are the things, and this is how the current situation is there. Now it's up to you, like how you can change this trend, and how you can bring this graph, this exponential graph, to very lower level. So I don't want any much of your money or something like that, but just if you found this video helpful, please share it to people to make them understand like these are the things. And just keep in mind that uh, follow all the safety regulations that are followed. Okay, and share this video to as many people as possible, so that they understand what are the importance, and how in the upcoming months it will severely affect the trend of this corona there in India and across the world. Not only India will be affecting, but all the other countries because of that. So to be on a better side, stay home, stay safe, and food is the best vaccine, that I would say. So just don't do any meetups or gatherings. Practice social distancing, and that's all for this video. On the next video we'll do some advanced things on this. So thanks for watching this video.